Hello everyone. Today I am going to discuss with you the most important concept, that is quantum numbers and their significance, presented by me. First of all, I will show you for quantum numbers different subshells with their orbitals. First is the S subshell, which is spherical in shape. Next is the P subshell, which contributes 3 orbitals, that is Px, Py and Pz. And next shell is about D shell. D shell contributes 5 subshells, that is 5 d orbitals. There is 5 d orbitals of 2 types. First is EG orbitals and second is T2G orbitals. EG orbital comprises of dx square minus y square and second is dz square. And 3 T2G orbitals comprises of dxy, dxz and dyz. Now, we are coming to our next point, that is quantum numbers. The definition of quantum number is that, okay, see here, the set of numbers which are used to describe the position and energy of an electron in an atom is known as quantum numbers. Okay. Now, there are 4 quantum numbers, namely as first is principal quantum number, second is azimuthal quantum number, it is also called as angular momentum, it is also called as subsidiary quantum number, third one is magnetic quantum number, and fourth and last is spin quantum number. Now we will study about designation of quantum numbers, that is in which letter these 4 quantum numbers are designed or designated. The 4 quantum numbers can be used to completely describe all the attributes, all the characteristics of a given electron belonging in an atom. For example, the first quantum number, that is known as principal quantum number, it is denoted by small n. Second quantum number, that is known as orbital quantum number or angular momentum quantum number, or it is also known as azimuthal quantum number, it is denoted by small n. Third one is the magnetic quantum number, denoted by m. And fourth one is the electron spin quantum number, which is denoted by m suffix s. Now, we will see about energy shells of an electron in an atom. Here there are 2 diagrams in which you will understand it very well. In your 11th standard, already you have studied that is in an atom, at the center it is a nucleus. The nucleus comprises of a protons and neutrons. Basically, nucleus is a positively charged, in which the circular shells are surrounded by this nucleus, and first shell is known as K shell. By numbering, it is also designated as first shell, second shell, third shell and fourth shell. These shells in letters can be designated as first shell, that is of n is equal to 1, that is called as K shell. Next shell is n is equal to 2, L shell. N is equal to 3, M shell, and so on. Now we have the question that how many electrons will contribute in each shell. The first shell, which is very closer to nucleus, it comprises of 2 electrons. Okay. According to the shell rule formula, that is equal to 2 into n square, where n is called as principal quantum number 1. When n is equal to 1, that is 1 square, that is equal to 2 into 1, that is equal to 2 electrons. Therefore, in the first shell, in the second diagram, you will see that is in the K shell contributes how many electrons, that is 2 electrons. Likewise, in the second shell called as L shell, how many electrons? N is equal to 2, that is 2 into 2 square, that is equal to 2 square equal to 4. 4 into 2 is equal to how many? 8 electrons. Third shell, n is equal to 3. 3 square equal to 9. 9 into 2, how much? That is 18 electron can contribute in M shell. And in the last shell, that is N shell, how many electrons? By taking n is equal to 4. 4 square is equal to 16. 16 into 2, that is equal to 32. That is, in general, K shell contributes 2 electrons, L shell contributes 8 electrons, M shell contributes 18 electrons, and N shell contributes 32 electrons. Now we will discuss about principal quantum number in detail. Basically, principal quantum number is denoted by n, as you know, as I already stated, and they designate or they show the principal electron shell of a atom. Since the distance between nucleus and the electron is described by it, that is called as n. However, the larger value of principal quantum number implies that or says that there is a greater distance between the electron and positively charged nucleus. That is, when n is equal to 1, the shell is very closer to a nucleus and there is a high amount of energy. This electron we cannot remove easily. Okay. Now, the value of principal quantum number can be any integer with a positive value, that is equal to or greater than 1. Okay. That is, it is not equal to any one of 0. Keep in mind, when n is equal to 1, that is of k shell, it is the one of the innermost electron shell of an atom, which corresponds to how much energy? That is lowest energy state, that is the ground state of an electron. But electrons are tightly held with and surrounding the nucleus. Thus, the principal quantum number, which is denoted by n, which cannot have the negative values or cannot have to be equal to a 0, because it is not possible for an atom to have the negative value or no value for a principal quantum number or principal shell. Now, principal quantum number. The another useful information, when an electron is ejected, that is from the higher level to lower level or lower level to higher level, what is the incidence going is on? In this incidence, we have says that when an electron is infused with energy, that is from excited state, it can be observed that electron jumps from one principal level to another principal level, that is one principal shell to another principal shell. At that time, the value of n to be increased, that is n is equal to 1 to 2, there is increase in value of n. Similarly, when the electron loses energy, once the electron goes into an excited state, it have absorbed energy. But when electron can jump from a highest excited state to lower excited state, at that time it emits the energy in the form of waves. At that time, the value of n also to be decreases. Thus, the increase in value of n electron is called as absorption, that is from absorption of energy from ground state level to excited state. The energy absorption takes place that by the electrons, and the process is called as absorption of energy. And while the emitting energy by the electron from higher excited state to lower ground state, it is known as the emission. Okay. Now, thus in this way we have described principal quantum number. The next number we are going to discuss, that is known as azimuthal quantum number. It is also called as angular momentum. It is also called as subsidiary quantum number. The specialty of this quantum number is that it describes the three-dimensional shape of a given orbital and the subshell in which the electron is belongs. That is K of subshell, which is subshell, that is 1s, 2s, 2p and etc. It is denoted by the symbol small l and its value is equal to total number of angular nodes in the orbitals. If number of nodes is equal to 2, the value of L is equal to 2. The value of azimuthal quantum number can be indicate that either the shapes of S, P, D or F subshell varies. The value of angular momentum or azimuthal quantum number depends on the value of a principal quantum number. That is, in other words, we can easily say that the value of a azimuthal quantum number is ranges between 0 to n 1. Now, the special category of this azimuthal quantum number to be discussed here, as the number of electronic jumps increases, here the number of lines increases at the same time. That is, for a given value of n, it can have the integral value from 0 to -7. Okay, for first shell, say for example k shell, that is n is equal to 1, we have only one value, that is L is equal to 0. For second shell, that is equal to L shell, n is equal to 2, we have the values L is equal to 0 and 2. That is, whatever may be the shell number, that number will be the values of, that will be the total number of values of a azimuthal quantum number. For third shell, for saying M shell, n is equal to 3, we have the values of azimuthal quantum number, that is L is equal to 0, 1 and 2. And for the fourth shell, it is about 0, 1, 2 and 3. Now, here I am showing you the pictorial representation of azimuthal quantum numbers. Here s orbital, yellow color indicates p orbitals, px, py and pz. Blue violet color indicates d orbital and green color indicates f orbital. Total number of orbitals for f is equal to 7, for d is equal to 5, for p is equal to 3 and for s is equal to 1. Okay. Now, for a specific energy level, the number of orbital shapes available to -1. Now, the representation of cell and number of electrons in azimuthal quantum number. See here, we have drawn a table according to energy level, subshell and maximum number of electrons counted to here. For the first subshell, which is called as S subshell, small s, how many electrons? According to shell rule, 2 into n square is equal to how many electrons? Already I have stated you, that is equal to 2 electrons. For subshell S and P, that is energy level is equal to second, how many electrons? S subshell contributes only 2 electrons and P subshell contributes how many electrons? 6 electrons. So, in which way? That is Px 2, Py 2 and Pz 2 electrons. That is, total electrons is equal to p orbital 6 electrons. So total S and P contributes how many electrons? That is 2 plus 6 is equal to 8 electrons. In case of third energy level S, P and D, d orbitals are totally 5 orbitals. Each orbital contributes how many electrons? 2 electrons. Therefore, 5 d orbitals contributes how many electrons? 10 electrons. Therefore, S, P and D equal to total 2 plus 6 plus 10, that is equal to 18 electrons. Already you have already studied in your 11th and 12th standard. I just remember to you. In the fourth energy level, how many subshells? There are 4 subshells, namely as small s, p, d and f. Each of the capacity 2, 6, 10 and 14. And out of taking its total, that is 2 plus 6, 8, 8 plus 10, 18, 18 plus 14, 32. Okay. Thus, we have got the energy shells and their maximum number of electrons present in the subshell. Now, we are going to discuss the third quantum number, that is known as magnetic quantum number. It is denoted by the symbol small a. The total number of orbitals in a subshell and the orientation of these orbitals in space, which is determined by magnetic quantum number. Underline these lines. That is, total number of orbitals in a subshell and the orientation of these orbitals in space, which is determined by magnetic quantum number. This magnetic quantum number yields projection of angular momentum corresponding to the orbital along a given axis. Okay. Now, also azimuthal quantum number, the value of magnetic quantum number will be depends on the value of L, and value of L is depends upon the value of principal quantum number. For each value of L, magnetic quantum number have the total number of 2L plus 1 values, which are ranges from -1 to +1 through including 0. But one thing should be kept in mind, that each orbital can hold a maximum of 2 electrons. Okay. Now, for a given value of L, the value of M ranges to -L to +L. Therefore, it indicates that Directly, it depends upon the value of n. For example, if n is equal to 4 and L is equal to 3, that is principal quantum number which is denoted by n is equal to 4 and azimuthal quantum number L is equal to 3 in an atom, therefore possible values of magnetic quantum numbers are, how many values are here? That is equal to 2 into L plus 1. That is already L is equal to what? 3. 2 into 3, that is equal to 6. 6 plus 1, 7. Therefore, 7 quantum number values for magnetic that are equal to -3, -2, -1, 0, +1, +2 and +3. Okay. Now, here the coordinately XYZ three-dimensional framework of s orbital and p orbital we have represented in this sheet. Here magnetic quantum number, it is described in three-dimensional orientation of a orbitals. Its value is already stated to you, -L less than or equal to m less than or equal to +L. Therefore, for any energy levels, there can be up to 1s orbital, 1s orbital, 3 p orbitals, 5 d orbitals and 7 f orbitals. Already see this diagrammatic representation for 1s orbital, for px orbital, that is this is of px orbital, py orbital and pz orbital. Okay. Now, the tabular representation of magnetic quantum number with a azimuthal quantum number. That is how the possible values of magnetic quantum number are arises. Here the table wise representation of this azimuthal quantum number and magnetic quantum number I have given to you. For first shell, it is denoted by 0, that is 2 into L plus 1, that is 0 shell level. Therefore, you have to put up instead of L is equal to 0 as I am stating in table 2 or table of column 2, 2 into 0 plus 1 is equal to 1. Therefore, possible value of m is equal to 0. For p subshell, the number of orbitals is equal to 3. Therefore, possible values of m is equal to -1, 0 and +1. For d level, it is number of orbitals equal to 5. Therefore, -2, -1, 0, +1 and +2. For f subshell, how many orbitals? 7 orbitals. Therefore, the possible values of m are -3, -2, -1, 0, +1 and +2. Thus, we can easily say that how the orbitals are formed according to the formula of using a 2l plus 1. Now, we are coming to the last quantum number, that is known as a spin quantum number. Okay. Now, this spin quantum number we have represented two diagrams here. Spin means that is orientation of electron in space. For example, when a hydrogen atom is considered, according to hydrogen atom, the electronic configuration for hydrogen is equal to 1s1. That is, one of the electron is present in its outermost orbital. When this hydrogen atom is placed in the magnetic field, each line in the spectrum could be separated into two lines, which was explained on the basis of electron which can act as a bar magnet, because in electron in which nucleus is present at the center, which spins about its axis with reference to its electron. Therefore, electron is considered as a tiny bar magnet. Here I have represented the north-south pole with direction of electron with one time clockwise and another time anti-clockwise. For clockwise and anti-clockwise, they have the spin. For clockwise +1/2 and for anti-clockwise -1/2. This spin quantum number was discovered in 1920. Two electrons in the same orbital do not have exactly same energy. The spin of an electron describes magnetic field which affects the energy. Now, the specialty of spin quantum number is that it represents the direction of spin of electrons. Also, this can be off in the direction of clockwise or it can be anti-clockwise. Now, what is meant by a clockwise? Clockwise spin represented by arrow pointing towards in upward direction, while anti-clockwise direction is represented by the arrow pointing in downward direction. Spin quantum number is denoted by the letter small s. It can have only about two values. One is plus one half, second is minus one half. Thus, spin quantum number uses the value only are 2, that is equal to plus one half minus one half. Now, again we come to all the quantum numbers, that is the summary of the quantum numbers. Here 4 columns are made for taking the summary. In first column, names of quantum numbers are written. In second, symbols are represented. In third, their values are represented. And in fourth, which is the most important part, or which is the significance of the principal quantum number, I will share you only, that is name and physical significance. First, all of you see here, that is the principal quantum number, which is denoted by n, which take the values 1, 2, 3, 4, comma, and it gives main shell in which the electron exists. Always it determines largely the energy of electron. Also it determines the size of the orbital. The next quantum number, that is the azimuthal quantum number. It is denoted by the symbol small l, which have the values in between 0 to n minus 1, and its significance is that is it gives the subshell in which electron belongs, the contribution of energy of electrons, and it specially determines the shape of the orbital. Third one is the magnetic quantum number, denoted by Mi. Its values are in between the azimuthal quantum number, that is minus L to 0, 0 to plus L. It determines the orientation of orbital in space. Last and most important is the spin quantum number, which is denoted by the small m suffix x. It have the values, that is of spin, it has values that is equal to 2, plus 1 half and minus 1 half, and it determines the orientation of rotation of electron around itself to prepare the direction of rotation about the nucleus, and this motion is always called as gyrometric motion or a precessional motion, which will study you on your BSc part 3.